Okay, we are live now. Hello, everybody. My name is Milen. We are waiting for my colleague Nikolai, who will join us after they finish. Okay, Nikolai, the stage is yours.
Hello,
good luck,
everybody. Thanks for joining the second session in the business applications track. This one is going to be very interesting. It's about energy knowledge graphs and how they facilitate the evolution of the European energy market. And we have two guest speakers for this one. I would like to introduce Chavdar Ivanov, who is a managing director at GridDigit. He's been working as a consultant for about 20 years, consulting organizations about power system modeling and analysis, data exchange formats, common information model and common grid model exchange, interoperability, and much more. And we're delighted to have Chavdar on this presentation here, together with our very own Vladimir Alexiev, our chief data architect. Both of them will talk about the evolution in the space. And yeah, without further ado, guys, the stage is yours.
Okay. Good afternoon to everybody. So we will start with a short introduction to the European power system. We can go to the next slide. So the power system and the energy market in general, it's a very complex system. The business processes include many parties, and as you know, a lot of interconnections and renewable energy sources are embedded in the system. So this happens over time, and recently there are some extensions or tasks related to the grid operation and development related to power system models and analysis. So what is important here to realize that high performance and interoperability is required for this system to be reliable. And the network model and the data management is something which is crucial in this picture. We can go to the next one. Yeah, we have strong legal requirements. As many of you most probably know, in Europe there is extensive set of legislation. They were initially packaged in the third energy package published in 2009, where actually NCE, the Association of the Transmission System Operators in Europe, and ACER, the Association for the Regulators, was established. And there were, besides many other things, two areas where there's a lot of data exchange requirements defined. For example, the network codes. You see three areas here: the connection network codes, the operation network codes, and the market network codes. And each of those have a substantial data requirement background. And we will touch on this in the next slide. The other piece is the 10-year network development plan, which is focused on the development of the grid for the next 10 to 15 years. You can go to the next. So looking at where CIM is used and for what purpose, let's look at the operation and market network codes. And here there are 4 different processes. The CSA is the Coordinated Security Assessment. The CGM is the Common Grid Model. The OPC Outage Planning Coordination, and the Status Short-Term Adequacy. And all of these processes have something to do with CIM, because CIM is the the governing information model that is used to model the data. And these processes are also interacting each other because, for example, the CGM, the common grid model, is something that all the utilities, the transmission system operators contribute with their data. And that artifacts, these models that they produce, are then used in the security assessment, in the coordinated security assessment. And you see there's strict deadlines, and so you monitors the implementation, but everything comes as a business requirements, as a regulation from the European Union. If we go to the next slide, we have a similar situation with the 10-year network development plan, where here you see many lines here on the chart. These are either new or updated projects. And in order to study these situations for 2030 or for 2040, grid data needs to be exchanged, scenario data needs to be exchanged. And talking about many parties here, more than 40. So CIM was selected to be the governing semantic model for that purpose. So if we go next slide. Yeah, and the one after. So we know that CIM is not that old, but it's already getting some experience. Started in the early 90s in the USA. And what we saw in the last 20 years, basically that Europe has a significant contribution to that, where the CIM for planning, CIM for dynamics were also cooperative efforts between organizations in Europe and US. But the whole requirements coming from the network codes, from the TYNDP, were bringing significant updates to the common information model. So it's an IEC standard. It's continuously developed. There are three series of standard, the 61970, 61968. It's about the distribution, and the 62325 is for the market. How this is used, it's mainly on three levels. We have inside utilities, where each utility can have it for their own purposes, but also use cases like we just mentioned for the 10-year plan and the grid model, the common grid model, or something which is international. To go further in the slide. So this slide here explains a little bit the benefits of using CIM in an enterprise. So there were a lot of systems that you need to integrate, and having multiple interfaces between different parts of the system, it's just more costly and difficult to maintain. And utilities are basically realizing that having a common information model and structured exchange, it's much more efficient. So that's why we want to use CIM as much as we can. So if we move next. Yeah, this is just a view of areas that CIM covers, and I think the time doesn't really allow to go into the details, but we see here a lot of areas of the electricity enterprise and distribution, transmission, the DER, the consumption, and all these areas have their mapping to the smart grid model and to the CIM in general. And in the next slide, you will see some information about the Common Grid Model Exchange Standard, which is part of the IEC CIM, and that standard covers 10 different profiles where people can exchange equipment of their grid or different information about the scenarios during the day or during the months or years. And the whole model is maintained in the UML, and you have just a view on that on the right-hand side. If you go to the next, further on. So the energy knowledge graph, so when they come to place, so we see that this fits quite well with CIM, but there are still some things to be done in CIM, and I think Vladimir after me will also go a little bit into details on that. But what we acknowledge in the CIM community is that we need to go close to the linked data principles, and there are certain things in CIM that could be improved to be more aligned. Go further. I think we are now going to the last piece of information that I want to introduce to you. This is the modeling of the constraints. That's something also very important for a process like the Common Grid model, because the data it's complex and it needs a lot of consistency checks between, for example, different parts of the model, equipment, and steady state hypothesis, or between different business processes. So traditionally, until now, OCL was used as a technology, but having SHACL approved as a W3C recommendation in 2017, now the community is looking to utilize SHACL as much as possible. And as you would see in the next slide, there is one visualization of what GraphDB can do with a schema and SHACL constraints. And me as a power system engineer, so for example, I'm interested to see an AC line and what constraints are connected to that. So I know that this is element of the schema. I know also that this is defined, that this should have some constraints, but the way to visualize and to be able basically to browse that information and to get oriented in the design is kind of important piece, especially for people close to the design of the constraints, but also could be useful for end users of the model. And similar thing can be also done to be linked with actual grid model, so to see what constraints were related to that. So with this, I think we can move to you, Vladimir. And
thank you. Okay, in the rest of the presentation, I'll talk about a project that Ontotext is just starting on. We have some commercial clients that use CIM, but we want to push CIM in the direction of using more linked data principles and being used not just for data exchange, but as a knowledge graph sharing model of energy data. And our project is about energy market transparency data. So Chavdar already mentioned ENTSU-E. It is maybe the most important electric organization in the world because it manages the coordination between 42 transmission system operators that represent 35 countries, whereas in the European electricity market, there is about 40 something, 45. So Europe represents the largest interconnected electric. And as already mentioned, all of these exchanges use CIM and the ENSUI extension CGMES for equipment info, static and dynamic balancing, congestion management, flexibility, all kinds of important network modeling tasks. The ENSUI transparency platform collects and publishes up-to-date data on electricity generation, transmission, consumption, flexibility management, and other aspects. It publishes both actuals and also forecasts, such as day, week, and month and year ahead, and it has full historic information. This information is crucial to ensure market efficiency of the pan-European electricity market. The information is collected by national TSOs and then submitted to ENSUI. It is mandated by European regulations. It's quite large in scope, about 100 data points or time series. And there are rules about the timeliness of the data. So I think every 15 minutes or so, for example, the actual demand and production are reported. And it uses the MADES standard, Market Data Exchange specification, that is also closely related to CIM. This is a screenshot from the ENSUI transparency website. So you see some selected diagrams. You can also choose diagrams of your own, and you can download data in XML format. As I mentioned, the scope of data is very broad, about 100 data points. So you see a bunch of time series describing load, generation, transmission, balancing, outages, congestion, and so on. One very important ingredient in making knowledge graphs is to have permanent URLs about entities, and this already exists in the energy domain. The EIC, Energy Identification Code, it's used not just for electricity, but also for gas, for example, by the ENSUG organization. So this is the Association of Transmission System Operators for Gas. And here are some examples of Bulgarian entities. You see the first one is the IEC for Bulgaria, which has functions control zone, bidding area, member state, and so on. This is the code for the Bulgarian TSO called Electrical System Operator. This is the code for the Kozloduy Nuclear Power Plant Company, which is a balance responsible party. It's structurally significant in the energy balance in Bulgaria and the region. This is the Kozloduy Power Station. It's called the production unit. And the final ID is of one of the reactors of Kozloduy. Currently, we have 2 reactors running. So this is an excellent foundation for building up an energy knowledge graph. Unfortunately, CIM says that GUID should be used, and CIM is currently only used for RDF XML data exchange, and even those GUIDs are not permanent. So engineering systems regenerate GUIDs on every export, and of course this makes it very hard to keep track of what old GUID corresponds to each new GUID. So we think that if CIM was slightly reoriented to comply with linked data principles, that will make energy data sharing much easier. Rather than having to send a message to somebody and ask for information, you can go to a well-known URL and get that information on demand, and it will be guaranteed timely information. We won a project as part of this European project called Interface. So we'll start towards the end of November, but we already, as part of the proposal, started working on this platform. I'll show some queries and how we convert the data and so on. The goals of the project are to combine semantic technologies and linked data for better utilization of CIM, to have every data item for energy transparency be addressable by a permanent URL, to integrate the data that comes from a variety of XML messages into a coherent knowledge graph, and then to be able to improve data validation and quality by using SHACL checking, because to our surprise, it turned out that the data, even though it is timely, there are quite a lot of inaccuracies in it. And also to provide a demonstration of cross-industry data exchange using knowledge graphs. Here are some of the data quality problems that we found in ENSUI transparency data. For example, we thought that a power unit and all of its generation units should be in the same country, right? You cannot have a power station and then some of the reactors of that power station are in a different country. But we found some exceptions. The reported capacity, nominal power of a power unit should be equal to the sum of the powers of its generating units. Or maybe should be bigger if the generating units are skipped, not described. But even this doesn't hold. Or in the IEC file, this is the basic information about market players and resources. You have VAT numbers of companies. Well, this should be valid according to the respective country format. And furthermore, they should exist in other systems that track VAT numbers, like the EU VAT information exchange system. But it turned out that there are some VAT numbers that are expired, and still the energy marketplace not marked as expired in the EIC. This is a simple model of maybe about 5% of the transparency data. Here the red things come from the IEC file. The blue things come from the installed power. So this says there are such and such companies, and this is the Kozloduy power station with its 2 reactors. And this here say what is the voltage and the nominal power for the station and for the reactors. Whereas these here green C's are code list values, nomenclature values. And even after integrating just a tiny bit of the data, we found some problems. For example, this and this reactor, they are both linked from the power station using these blue links. And this reactor correctly reports that the parent unit is MPP Kozloduy. But this one has a mistake. It points to the thermal power plant Marica Istok. Just a few words on the architecture of the platform. So we get data from ENSUI XML format using either API or queuing. And then we use XSparkle, which is a declarative language for some raising the data for ETL. We store it and do inference in GraphDB. Put an Ontotext platform instance on top of it. The semantic object modeling language, which provides GraphQL querying of the data, simpler querying. And on top of the platform, we have Grafana for monitoring, Elasticsearch for full text and faceted queries, and Kibana for analytics. You see a couple of charts at the very end that are done with Kibana. This is a sample script. This converts the IEC XML into triples. So it's a sample of this XSparkle language. And you use coordinated URLs between different scripts that handle different XML messages. Then you get a knowledge graph with coherent integrated information about the complete transparency data. And it also removes unnecessary differences like this, for example. So the IEC code you see here is the property transparency IEC, but in the different XML messages, it uses different namespaces. So this would make the XMLs harder to query. This is an example of GraphQL querying over a knowledge graph. And because we generate a schema and there is schema introspection, it knows the property names. So I made a mistake here and it tells me which properties I can use right at this spot. So what are the properties of an energy resource? The result is JSON that is the shape of the query. So that's why GraphQL is very much loved by modern applications. And I think this is the last slide, some charts done with Kibana on top of the Ontotext platform. So Ontotext platform drives the indexing of data into Elasticsearch. The source of the data is RDF. And here's a little block that introduces this project, and this site is Ontotext.com, where you can take a look at the different information that is presented. Okay, now we have some time for questions.
All right. Thank you guys for being exactly on time. So I have a question. Let's start this off. There are many versions of CIM. So which one is the one that we should look at?
CIM is a series of standards, a family of standards. Chavdar mentioned 3 series, but each one of them has many parts, between, I don't know, 5 and 10 parts. And yes, CIM evolves in time. So as new things are added to the scope, CIM is now at version 17. I would say that depends on the project. In a greenfield project, of course, we should use the latest. But if there's already some data, large amounts of data using an older version, then we could create conversions to the newer or just use the older version, as is.
Yeah, it's very important to start from the last one, and all the vendors and integrators should be actually able to move from one version to another quickly, because the business is expecting that.
All right. And another one. Which are the entities that would need to process the data and run the processes? Chavdar, maybe to you.
Yeah, so basically I said a little bit in the beginning on that. For the common grid model, we have all the transmission system operators in Europe, but we also need to think that there are some of the methodologies in the codes which require interaction between the transmission and the distribution. So companies, there's then a big list of companies of the distribution system operators that will be involved.
All right. There's one question that comes from the audience. Please explain in detail how to visualize SHACL constraints. Do you define links for representing relationships between constraints?
Chavdar has shown a diagram that comes directly from the built-in graph in GraphDB. But yeah, this only shows the connections. So it says there is a node shape for AC line segment. There is attached to the class AC line segment, and it has these 4 property constraints, whereas this one has, I don't know, 15 or 20. But to see what exactly are the constraints, I think that other ways of visualizing are better. I personally think called the Sparna SHACL playground, and we tried to run the CIM constraints through, and we got some results. They are not, they're still suboptimal. I think I can find them here.
And actually what you also see in the slide, if you, especially in GraphDB, if you click on one of these property shapes, you see the content. So you can immediately see what is inside the constraint.
All right. We have about a minute left of this. So I'm sure that we can discuss those subjects offline. We can connect through the platform, or you can reach us out or our emails. You will see the presentation. It will be distributed to everybody. With that, Chavdar, Vladimir, thank you so much for the presentation. And to the rest of the audience, we've seen how complex this data can be, and it can lead to a lot of messy subjects. So I invite you to our next session that starts in a bit, where we talk about how to clean some messy data up. Thanks, everybody.
Thank you.
Okay, thank you.